Okay, so we're starting here with what looks like a circle formula. Okay, x squared plus y squared equals 25. And what we're going to do is expand the graph by a factor of 2 vertically and shift the graph to the right. So basically we're going to start with this circle. We're going to stretch this graph vertically. So I'm going to take that graph and I'm going to stretch, I'm going to stretch it vertically. Okay, and then I'm going to translate graph 3 to the right. Okay, so we're going to end up with a graph that ends up something like that. Okay, so what does this look like? Okay, so what's the equation of this going to look like? Okay, so I'm going to show my transformation. So vertical expansion is going to be y over 2 squared, or the b value is 2, so this should be y squared over 4. The translation of the graph to the right, so it's going to be x minus 3 squared. Okay, so there's my transformation, my translation. There's my expansion, and that should be equal to, we're just going to make it minus 25, okay, equals 0, and then we expand this and put it into general form. So expansion becomes x squared minus 6x plus 9. So notice that d value is affected when we have a translation. Okay, and in this case here, we're going to get y squared over 4 minus 25 equals 0. And so the c value is going to be affected by the expansion compression. Now, this c value, since it's a fraction, we need to multiply through, so it does in the end affect the x. Although it doesn't change the x-axis radius, it's the ratio of the a to c ratio is going to change. Okay, so then I want to get rid of that divide by 4. Okay, so times everything by 4. And my final general form equation becomes 4x squared minus 24x. Okay, oops, I should put it in the right order. Plus y squared minus 24x. There's no y term, and then this becomes plus 36 minus 100, which is minus 64 equals 0. So there it is. So notice that the coefficients were equivalent here, they're not equivalent here. So that's an indication that it's asymmetrical, and it gives us the amount of asymmetry. So this is going to be two times narrower than it was before. Okay, so what about this one? So if I translate to the right, I should have some effect on D. Okay, so what's the effect on D? And we're going to try to generalize this as well. So we'll put in the translation factor. X, do 3 to the right, is going to be x minus 3. That translation is going to affect that f value. That's really very vague how it affects it. Okay, in this case here, it's going to affect, we'll take a look at it later, but it's going to affect the kind of proportioning, the size of the ellipse, but it's not necessarily going to affect the positioning as we change that. Although changing this does change that value. Okay, but the changes are going to be expressed in the d. So when we expand this out, we get 4x squared minus 6x plus 9 plus 16y squared minus 64 equals 0. That 64 does get affected, but it is not affecting the size of it. Okay, so we end up with 4x squared minus 24x plus 36 minus 64. So I should write this in the proper order. 16y squared, so there's my c value, minus 24x plus 36 minus 64. That's going to be, well, I should just write that out, plus 36 minus 64 equals, and this should be 28. So 4x squared plus 16y squared minus 24x minus 28. Okay, so one thing I just want to note, this f value, it does affect things, but it's mixed in with horizontal shifts, vertical shifts, and expansion compressions. Okay, so that there's an effect that it can be affected by all of those. So this doesn't tell us a lot how it changes. However, the change in the D here, so the change in the D went from 0D to, 0x to negative 24x. So that's our change. So how is that affected? Well, we can kind of see how that's affected. We're going to have that expansion compression factor is going to affect the value of the D eventually. So that's going to be affected here. The shift doubled is going to give us that, and then it's going to be affected by that. So what we can say then is our change in D is going to be affected by 4, so it's going to be A times 2 times change in B. Maybe I'll write this a little bit differently. Not change in B, but change in P. Okay, so the change in P is our 3 here. It's going to be times, we're going to double it, and it's also affected by the A factor. Okay, so this is how our changes are going to be affected. Okay, and we'll put a negative there because P, we should say that the P is at +3 change. Okay, where P represents our horizontal shift. So it's fairly complicated looking at the relationship. However, there is this connection back to Viete's formula. So the P value is B over 2A. Well, this is D over 2A. Okay, and D and B are actually the same coefficients when we look at the quadratic versus the parabola versus this quadratic. Okay, so that's a fairly complicated relationship. What we want to do is be able to track this here. Okay, this is kind of very advanced. Okay, this is generalizing, and this is really hard to do, and we're not really going to do a lot of that, but I wanted to show you that there is this connection, and it actually is connected to Viete's formula.